So we have seen earlier that in the case of a plane mirror, the object distance is equal to the image distance, and the line joining the object and the image must be perpendicular to the mirror. And we've also seen that the image is virtual. So now what we're going to do is we will try to move the object and see what happens to the image. So movement of object and the mirror. So first we'll start or we'll look at what happens to the image when we move the object, and later on we will see what happens when we move the mirror. So let's start with the object and let's move it along the mirror, and then let's see what happens to the image. So we have a plane mirror like that, and let me shade or let me coat silver to this side of the mirror, and we have an object over here, right? So now in order to place the image, what I'm going to do is I'm going to draw a line passing through the object perpendicular to the mirror like this, and I'm going to place the image over here such that the object distance is equal to the image distance. So this is the image location I, and the object distance, let's say, is d, so the image distance will also be d. So now what I'm going to do is I'm going to displace this object. I'm going to move this object along the mirror, so that will be in that direction. So this is 90 degrees, right? So I've moved the object along the mirror, and this over here is the new position of the object. Let's call it O dash. Now what about the image? Well, to find out where the image is, I'm going to draw a line again through O dash and perpendicular to the mirror like this, and I'm going to place the image over here such that the object distance is equal to the image distance. So this is the new image location I dash, right? So if you look at this figure, so the object distance was d. Now in the later case also the object distance must be the same, right, because you are moving the object along the mirror. So therefore the new image distance will also be d, right? So if I join the image locations, the old and the new image locations, I'll get this line like this and this arrow. Now, well, if you look at the quadrilateral formed by O dash, I and O, the sides O dash, I dash and OI, they are parallel to each other and they have the same length, 2D and 2D, right? So if you look at O dash, I dash, its length is 2D, right? Similarly, if you look at O and I, its length is 2D, and these two lines are also parallel to each other. And we also know that this angle over here is 90 degrees and this is also 90 degrees. Now what that means is this quadrilateral is nothing but a rectangle, right? This is a rectangle. Now what that means is that the length of the line I dash is equal to OO dash, right? So if the object has moved by a distance let's say L, the image has also moved by the same distance L, right? So what we are seeing is whenever we move the object along the mirror, the image will also move by the same amount in the same direction, right? For example, instead of moving the object in that direction, let's say I moved it like this, right? Now in that case the image will also move by the same amount in the same direction, so it would be over here, right? So what I can say is if the object is moving along the mirror, then the image will also move along the mirror in the same direction. So let me add that point. So if the object is moved along the mirror, the image will also move along the mirror by the same amount in the same direction. So now let's look at the case where the object is moving perpendicular to the mirror. So the object is moving perpendicular to the mirror. So let me again draw the mirror like this, and let's coat it with silver on this side. Okay, so we have an object over here. Now to position the image for that object, again I'm going to draw a line through object O and perpendicular to the mirror like this, and then I'm going to place the image over here such that the object distance is equal to the image distance. So let's say the object distance is d, So the image distance will also be equal to d. So now what I'm going to do is I'm going to displace this object perpendicular to the mirror, which means I'm going to displace it along this line. Okay, let's say I displaced it, and this over here is the new position. Let's call it O dash, and let's say this distance is d dash. Okay, so the new object distance is d dash. Obviously the image should also lie on the same line, and the image distance should be d dash. So the new image distance, this one, is d dash, right? So now look at the amount by which the object got displaced. Well, it is basically this distance, right? And that is nothing but d minus d dash, right? Similarly, if you look at the image moved by this amount, and that is also equal to d minus d dash, right? So the image got displaced in this direction and by an amount which is d minus d dash. So what you are observing here is that the object and the image basically displaced by the same amount, right? The distance moved by the object and the distance moved by the image are same, but the only difference is the direction is different. In this case, the object moved towards right and the image moved towards left, right? So they moved by the same amount, but then the directions are different. They are opposite in nature. So what I'm going to do is I'm going to add a line. So if the object is moved perpendicular to the mirror, the image will move in the opposite direction by the same amount, right? So if the object moves towards right or towards the mirror, the image will also move towards the mirror, but if you look at the directions, they will be opposite. So if the object is moving towards right, the image will move towards left, or if the object is moving towards left, the image will move towards right. The directions are opposite, but then the amount by which they are moving or their distances are same. If the object is moved by a distance, let's say 10 centimeters, the image will also move by a distance of 10 centimeters. So that's what this means. So we have seen what happens to the image if the object is moved. Now let's look at what happens when the mirror is moved. So we'll start with the case where the mirror is either moving forward or backward. So what that means is, let's say we have a mirror like this, and let's say that it is coated like this, and we have the object over here, and the image will be on this line which is perpendicular to the mirror, and the object distance will be equal to the image distance. So let's say the object distance is d, right? So the image distance will also be equal to d. So now what we are doing is we are trying to move this mirror backwards. Let's say I'm going to move this mirror backwards. All right, so this one. So let's say that is the new position of the mirror. So I'm going to differentiate it by drawing it thinner like this. So this is the new position of the mirror, and let's say that we have moved the mirror by a distance x. So this distance is x. Now clearly you can see that the new object distance has become d plus x, right? So this is the new object distance, and that has become d plus x. So if I point out, or if I locate the new image, again to do that I'm going to draw a line which is perpendicular to the mirror, and the new image will be somewhere over here, such that the new object distance is equal to the new image distance. So this image distance should also be equal to d plus x. Okay, so now if you look at, or let's do one thing, let's name this new image as I dash. Now try to observe the distance between the old mirror location and the new image, and that distance would be it is this distance, right? And it is equal to d plus x, so that will be d plus 2x. Okay, So now if I observe the distance moved by this image, it would be this distance, and that distance is nothing but d plus 2x minus d, right? So d plus 2x minus d is simply 2x. So therefore you can see that the image has moved by a distance 2 times x. So if the mirror moves by a distance x, the image will move by a distance 2x. So here in this case, the mirror has moved backwards, right? It's moved away from the object. So I'm going to call it as backwards. So the image has also moved backwards, but the distance it got moved is twice that of the mirror. So if the mirror moves by a distance x, the image will move by a distance 2x. Alright, so let me add that point. So if the mirror is moved forward or backward by a distance, the image moves forward or backwards respectively by double the distance. Okay, so if the mirror moves forward by x, the image will move forward by 2x, and if the mirror moves backwards by x, the image will move backwards by 2 times x. So that's what it means. So now we have seen what happens if the mirror moves backwards or forwards. Now let's see what happens to the image if the mirror is moved sideways. So we have a mirror like this, and it is coated like this. Now let's say we have an object over here, and to find out the position of the image, I'm going to draw a line through the object perpendicular to the mirror like this, and the image will be at this point such that the object distance is equal to the image distance. So well, we know that this line is perpendicular. So now what I'm going to do is I'm going to move this mirror sideways. So the new position of the mirror will be like this. So the mirror has moved by this much. Okay, so where will be the new image position? Well, you can clearly see that the image position will not change, right? Because the line joining the object and the image must be perpendicular to the mirror. So if you look at this line, that line will not change, right? So what we can say is, again, the object distance must be equal to the image distance, and the image must be lying on this line. So therefore the position of the image will remain the same. So whatever was the position of the image, the new position will also be the same. So basically the image will not move. So whenever you move the mirror sideways, the position of the image is not going to change. So let me add a point. So if the mirror is moved sideways, then there is no change in the image location, right? So whenever the mirror is moved sideways, there will be no change in the position of the image. Now let's look at a problem. So in this problem, we have an object which is moving at a speed of 1 meter per second towards the mirror. So we want to find out what is the speed of the image. So if I represent the mirror, it's like this, and let's say that this is the side coated with silver, and here we have an object, and this object, let's call it O, is traveling towards the mirror at a speed of 1 meter per second. So we need to find out what is the speed of the image. So we know that whenever the object is moving perpendicular to the mirror, the image will move in the opposite direction. So over here, if I say that this is the image will be moving the opposite direction. So it will be in this direction at a speed of, well, what is the speed? Let's say the image is moving at a speed of 2 meter per second. Alright, the object is moving at a speed of 1 meter per second towards the mirror, and the image, let's say, is moving at a speed of 2 meter per second towards the mirror. So what happens over time is, if the image has 2 meter per second and if the object has 1 meter per second, after some time the image distance is going to decrease much more than the object distance, right? Because the image is traveling faster towards the mirror, right? But we know that the object distance and the image distance should always be the same in the case of a plane mirror. So therefore, if the speed of the image is not equal to the speed of the object, what happens over time is the object distance will not be same as the image distance. So therefore we can say the speed of the image should always be equal to the speed of the object. So the speed of the image cannot be anything else other than 1 meter per second, right? So only in this case the object distance and the image distance will remain the same always. So the speed of the image is 1 meter per second and it is traveling towards the mirror, which is opposite to that of the object. So we have one more question. So in this question there is an object in front of a plane mirror and the mirror is moving away from the object at a speed of 4 meter per second. What is the speed of the image, right? So let me represent the mirror, right? And we have an object over here, let's call it O. So it's given that the mirror is moving away from the object at a speed of 4 meter per second. So the mirror is moving away from the object at a speed of 4 meter per second, and we have an image over here. Now we need to find out what is the speed of the image. Well, we know that if the mirror moves by a distance x in the forward or backward direction, the image will move in forward or backward direction respectively by a distance of 2x, right? So if you displace the mirror backwards by, let's say, 10 centimeters, then the image will get displaced backwards by 20 centimeters, right? Or if you displace the mirror forward by 10 centimeters, then the image will get displaced by 20 centimeters in the forward direction. So therefore whatever is the speed of the mirror, right, in this case the speed of the image will be twice of that, right, because the image is covering twice the distance as compared to the mirror. So therefore I can say that if the mirror is moving at a speed of 4 meter per second towards right, the image will also move towards right, but it will move at a speed which is twice that of the mirror, so 8 meter per second. So that is the speed of the object. It is 8 meter per second, and the object will be moving in the backward direction. Now let's look at a problem. So in this problem there is an object in front of a plane mirror, and this object is moving at a speed of 5 meter per second away from the plane mirror, and the mirror is moving away from the object at a speed of 2 meter per second. So we need to find out what is the speed of the image. So let me draw the mirror first. So we have a mirror like this. Let's say this is the silver coated side, and we have an object over here. So this object is moving away from the mirror at a speed of 5 meter per second, and this mirror is moving away from the object at a speed of 2 meter per second. So we have to find out what is the speed of the image. So image will be somewhere over here, and we need to find the speed of it. So well, we know what happens to the image when the object is moving. We also know what happens when the mirror is moving. Now in this problem, both the object and the mirror are moving. So how to solve this? Well, what we can do is we can try to split this problem into two different parts. And in the first part, so I'm going to break this into two different parts, and in the first part I'll say that only the object is moving. Alright, so in the first part only object is moving. So let's say the mirror is not moving, only the object is moving, and the object is moving away from the mirror at a speed of 5 meter per second. Now we know that whenever the object is moving perpendicular to the mirror, the image will also move by the same amount but in the opposite direction, right? So therefore in this case, as this object is moving away from the mirror with a speed of 5 meter per second, the image will also move away from the mirror at a speed of 5 meter per second. In other words, if this object is moving towards left at a speed of 5 meter per second, the image will also move at a speed of 5 meter per second, but it will move towards right. So if I say only object is moving, and then in that case if I represent the speed of the image, it will be 5 meter per second in that direction. In the second part, I'll consider that only the mirror is moving. So in the second part, only the mirror is moving. Now if only mirror is moving and if the object is at rest, we know that whatever is the distance moved by the mirror, the image will move by twice the amount. So in this case, the mirror is moving towards right with a speed of 2 meters per second. So what this means is the object is at rest. So if the mirror is moving at 2 meters per second towards right, the image should also move right but with double the speed. So therefore the image will move towards right at a speed of twice that of 2, which is 4 meters per second. So what we have done is we have broken down this problem into two parts. In the first part, only object is moving, the mirror is at rest. So if the object is moving at a speed of 5 meters per second towards left, then the image should move at a speed of 5 meters per second but towards right. And in the second part, I've assumed that only the mirror is moving and the object is at rest. Now if the mirror is moving at a speed of 2 meters per second towards right, the image will also move towards right but at a speed which is double that of the mirror. So the mirror is moving at 2 meters per second, so the object will be moving at 4 meters per second towards right. So now what I'll do is I'll combine the motion of the image from these two parts. So in the first part it says that the image is moving towards right at 5 meters per second. The second part it says that the image is moving towards right with 4 meters per second. So if I combine both of them, I will see that the image is moving towards right at a speed of 5 plus 4, which is 9 meters per second. So that is the overall speed of the image, 9 meters per second towards right.